Thank you for joining. We'll get started in just a minute to let some stragglers dial in, so sit tight. Thanks for joining. My name is Cassie Rowe, Content Marketing Specialist at 451 Research. Today's webinar, Industrial IoT, What is Missing and What is Next, will be presented by Ian Hughes, Senior Analyst of IoT, and Emily Wentworth, Research Associate. Before we dive into the content, I just want to give a brief introduction to 451 Research for those of you who aren't familiar with us. 451 Research is a top-tier research and advisory firm headquartered in New York City. Our team of more than 100 analysts cover more than 2,000 technology vendors and service providers every year. 451 Research provides insight into emerging disruptive technologies and the companies taking them to market, and deliver that insight via syndicated research, advisory services, and live events around the world. Before I turn it over to today's presenters, I have a few housekeeping items. The first and foremost is our Hosting Cloud Transformation Summit is coming up this September. It's our 14th annual iteration of the summit, and we highly recommend that you join us there September 21st through the 26th in Las Vegas. If you use the code IoT200 when you go to register, you will get a $200 discount on your registration fee, and it is available from now until August 15th, and the link is right there. The webinar slides are also available in the attachments and links section of the BrightTalk platform, where you can access this link and many others that will be in the presentation. You can submit questions to the presenters in the same platform for the Q&A at the end of this webinar. And the recording of the webinar will be available immediately after today's session. Without further ado, I'm going to turn it over to Ian.
Hi, thank you very much, and thank you all for joining on this very warm day across the entire planet. So we're going to talk about industrial IoT and said what's missing, what's next. I'm Ian Hughes, Senior IoT Analyst, and you can find me online as ePredator. So if you want to contact me, just hit me up there. So we're going to give you a little bit of an intro and an IoT level set, just to let you know where we are, and so we're all on the same page, and try and describe what's going on with industrial IoT transformation and the problems and challenges that are in there, and particularly looking at the move to everything as a service, and also the importance of people in this whole thing. So there's a lot about automation, but people are very important within the whole industrial ecosystem. A little bit about security and trust, because we can't do an IoT presentation without security, because that's a real problem that we have to consider. And then we've got a Q&A at the end. So feel free to pop your questions in, and we'll try and get to as many of those as possible towards the end of the presentation. So Emily and I both work in the Internet of Things channel within 451. You heard the intro there. We cover an awful lot of technology fields in 451. But IoT is particularly underpinning lots of those areas as well now. So whilst it's a channel, we work with all the other channels as well. So we're not totally isolated, as you might see from that picture. And I always like to start with this, because just to begin this level set, because IoT does impact and will impact every organization. I don't expect you to read all the things on this eye chart. We call this the pinwheel of death. It's the thing that we look at and say, wow, there's a lot going on. So IoT is a large, impactful change. It's not just about sensors and actuators, and it's not just about tiny little messages flying around. There's a whole set of challenges that organizations are going to have, particularly as IoT is a big silo buster. It comes in, the data it generates and the things that it gathers messes with your organization completely, and who does what job and what the role of particular parts of your organization are, which is a good thing because that disruption can lead to an even greater future. But it's a thing that you have to consider. But we're primarily here talking about industrial IoT and what happens in the manufacturing and industrial industries. And just as a bit of a level set, if we look at what has happened to get us to the point that we're at now, at the top of this picture is a representation of a traditional, and by traditional I'm going back hundreds of years, possibly even thousands, but in this case, around about 1800, the Jacquard weaving loom is a prime example here. There's an industrial machine at the heart of this in a difficult or awkward environment. It's doing something. It's doing a piece of work. There's some degree of remote operational control. You're feeding stuff into it. In case of the Jacquard weaving loom, it was controlled by punch cards, not digital punch cards, but mechanical punch cards that set it off on its way. So there's a very low resolution input to that machine. And there's a very low resolution of data coming out of that machine, because in this case it's the physical product. Is it working? Has it worked? Are the threads broken? Does it meet the quality standards? And there's a dotted line feedback back to the operation center and operation control, the people running it. It's not an electronic thing. Obviously in 1800 is this working? Can we fix it? And then we move down to where we are sort of now and moving on. And the picture's pretty much the same, but we've got a much higher degree of resolution of things both going into that we can control, typically digitally, into the machine and into the environment that it works in, and a lot more pieces of information and instrumentation coming out to tell us what's happening with that machine. And that information is now a big pipe of data that's able to come back to the remote operation control, the operation control center. So the production managers get to know a lot more about what's going on with the process. So really, as we often say, it's not new. IoT certainly isn't new, and industrial IoT isn't new. It's the resolution and the amount of data that we're flying around and able to operate on that is increased. And if we take that model a little bit further, back at the top again, the older machines had things that would automatically respond to certain stimulus. So, for instance, thermostats and steam governors, they are pieces of hardware set to say, well, when this happens, trigger this and stop that machine from overheating, or release the gas to reduce the pressure in that environment. But now we've got a whole host of data coming back from the machines. Some of it is a bit like the equivalent of those thermostats and governors needs. It has to happen right at the edge. So edge analytics has to look at what's going on with that data and tell that machine to slow down, speed up, turn itself off for safety. Proper edge control stuff within the production environment. So that's in what we call operational technology space. That is the factory, and that is the machine. But then some of that data is actually more useful to come back to IT departments, to places that are running machine learning or running AI processes and analytics processes to analyze the data. And it might be that that's data about all the factories or all the machines in a set of factories across many geos to come up with some sense of what's going on with them. And here we then get the first kind of clash between the OT people and the IT people. So two parts of the organization, the production people that are running the thing, they are engineers, mechanical engineers, and the IT people that are software engineers. Now, they've both got engineering in the title, but there are fundamental differences with how those parts of the organization in any enterprise would work. And when they work together is when things start to go well. But initially, you can see that there's a sudden shock to the system for both of A, why are you giving me all this data, and B, leave my machines alone because I'm trying to run this main production. And that complication is enhanced by the fact that even within industrial, if we just take manufacturing here, within manufacturing, there's a difference between the kind of patterns that you get in discrete and continuous manufacture. So continuous manufacturing is typically simpler in a certain sense, that there's a recipe, there's a thing happening kind of close in to put something together that's going through. It might be toothpaste, it might be dog food, it could be steel, but it's everything's kind of localized to one point. There's a few instrumentation points on that recipe, but and the quality of the stuff coming in is maybe measured, and then the quality of the stuff coming out, but it's relatively low amounts of data needing to be processed, as opposed to if you then start instrumenting a discrete manufacturing process where you have multiple components. If those multiple components have never been instrumented, that really doesn't matter. But if they are now, so you now know the size and the shape and the state of all the pieces that you're putting together, you end up with a much higher number of data points that you're trying to deal with, and a much more complex thing as you try and assemble these multiple items and shift them along the production line. Now that gets even more complicated if the thing that you're building is then going to be instrumented itself, if it's actually born connected and born as an IoT device. So as it goes out into the world, it's down in the bottom right-hand side of this graph here. It's likely to be, lots of products highly dispersed all over the place, depending on what you're shipping. But they probably don't have very many instrumentation points compared to some of the other things that you might know. It might just be, is it working, is it on, is it operational? And it's not going to be necessarily as high as the number of things that had to put all those things together. But at the same time, we've then got kind of continuous infrastructure. So we've got things like electricity and water, and those things are fixed pieces of infrastructure, so they are quite highly distributed, but maybe not as much as products that fly all over the place. But they've got quite a high number of instrumentation points to maintain all that set of balances across something, and say like the electricity generating network. So it's not a one-for-one. It's not just a very simple, this is IoT, turn it on, get some data. You've got lots of different attributes and lots of different things within manufacturing to consider. And also, if you compare what manufacturing and utilities may be doing and their focus compared to something like finance or healthcare, they are all interested in elements of connected and information-rich devices. But from our survey data, we see that, and quite clearly it would make sense, that manufacturing is looking to optimize its processing. So it's trying to make stuff that it's doing better and easier and safer, as opposed to maybe some of the other more customer-facing things that are trying to engage with those customers and change the nature of their products. So again, you've got two completely different sets of views of why you might be doing that IoT set of rollouts. And so optimization is a very important part of manufacturing, and one that we certainly see happening and talk about a lot. Now, but then when we ask people, where do you get your endpoint data from? On this graph here, at the top, we've got, again, quite obviously, OT people, factory people, production managers will say most of our stuff is coming from industry-specific field equipment. That's what you do. That's as I said, we're optimizing those elements. And at the bottom, we've got IT people who are going to say, well, most of our stuff is coming from data centers, so that makes sense. They don't have to necessarily be related in any way, but in the middle, we've got stuff that applies to both sides and to all enterprises. It's, you're getting data from your, it's very topical at the moment, air conditioning unit. You're getting data from your buildings. You're getting data from your surveillance and your properties and your infrastructure that is around, in this case, both your IT and your OT. And again, we're getting a clash of who is responsible for that, who does it matter the most to. So it's an interesting area to look at, to say, well, again, that's another complete cut through IoT and through industrial IoT when those IT-heavy endpoints and IoT-heavy endpoints kind of come together. So it's a real unusual environment to be. Every time you just think it's simple, there's some other kind of balance you have to look at. And I like to kind of show this slide a lot because this is informing us about what is going on as OT develops and as IT develops. So at the top, operational technology, manufacturing, back in from 1900s and before that, the size of the box, the height of that box is how many different ways people were doing things. If you think there's lots of custom involvement, lots of specific ways of doing things, specific manufacturers, it's not coalesced at all. But as we start to get into the 1960s, we start to get more computerization, more electronics into the environment. So a few more standards start to form because they have to. That's the kind of nature of what happens when you start to connect things digitally. You start to get that coalescing. And then that moves down into what's kind of happening now, in that more of the existing infrastructure, all these machines that have some have been working for hundreds of years, these machines are not designed to be connected to one another and do all this fancy stuff that we're talking about, but you can do brownfield wrappers on them when they're already electrically controlled or electronically controlled, to put some devices on them or near them to make them instrumented. So it doesn't require you to rip out all your expensive stuff and all your legacy equipment that's actually running your business. It's a layer that you can put onto those devices. So it's a brownfield wrapper, as we say. And eventually, though, the things that those machines need to do and the cycle time of those machines over years, they become these IoT pieces and industrial IoT pieces become core parts of the actual device in the first place. So we end up with lot fewer ways, more standard ways of doing it, but it becomes kind of nice and organised. Hopefully, there's going to be differentiation in some places, but the same thing has happened in the IT industry, in that we used to have lots and lots of ways of doing things, and then we started kind of getting into some degree of standards around building kind of client-server infrastructures. And then that's now moved to, with the move to cloud particularly, there's become increasing focus and standardization on being able to do things like containerize your applications. And now we're moving to serverless architectures as well, breaking things down into the service that you need, not into the let me build a giant monolithic application. And those things and those techniques that have got us to that point are being adopted by OT. So OT has now moved into being software, as not just hardware, not just mechanical engineering. And so they're able to leverage all these things that have been evolved by the IT industry. I'm a programmer by trade, so I'm going to say that we kind of helped invent, but they're able to leverage those. So you now see machines that are containerized, or machines that can run virtual machines, not machines that have their own embedded code that nobody else knows how it works. But at the same time, of course, we've got the typical tech bubble and trend of IoT. IoT turns up and says, well, we're all going to have a go at trying to do all these things. So we end up with lots of platforms, hundreds and hundreds of platforms, probably about nine. I mean, we've lost count, but we did have a list of 700 or 800 IoT platforms. Those platforms basically all end up doing the same thing, that they're going to resolve down to a set of standards quite quickly, hopefully, and then that will resolve down to some interesting patterns and design patterns that will fit both on OT and IT. But we're still in a little bit of churn on that, particularly with the number of patterns we've got. And that leads us to what's missing. And for me, when I look at all these deployments, we seem to be missing the architecture and the software engineering parts in describing and documenting what these things that are being built are. There's lots of platforms that say, well, we're a no-code platform, just configure this. There's lots of just plug this in and it'll work. But architecturally, across an entire environment, we used to document things. We used to build enterprise architectures. We used to describe those things. And then the artifacts from those we used to build and model in UML and things like that. And we used to have standards that sit alongside those. They do still exist. They're very much IT-based, but I'm not sure that they've moved into the OT crossover. I don't see them mentioned a lot. And equally, some of those may not be relevant anymore, because a lot of the engineering that goes on, and software engineering, is around training AIs or training models, which is completely different from sitting and building code. And we're missing the kind of methodology and pattern piece, which I showed in the previous slide. Patterns will appear, but we haven't got the way to describe those patterns yet. I don't think that's happened because we're still in a kind of a Wild West approach of trying to get people connected, and eventually those patterns will appear. But it's going to be an interesting thing to see what happens in that gap as well. There's also this slight problem or challenge that many organizations are going to have, that everything's going to be moving, everything needs to move to be a service. So if you used to manufacture packaged goods of some sort, you would, it didn't matter what it was, you'd be in the invent stage, which is the little light blue box at the top. And then you'd build it and manufacture the thing, and then you'd ship it. And when you ship your device, your thing, it goes out to the market. There's a dotted line there out to the market because just as before with the whole production process, the thing that you've shipped, you no longer have any connection with. You are not, you might see your sales figures kind of quarterly or something like that, and you may well get customer feedback, but you don't actually know what's going on with that thing. So the next time you have to invent or upgrade it, you're working on a little bit of guesswork. I mean, there's all sorts of things you can do, but you're not fully instrumented. So now, though, we're looking at things turning into being a live service. So you invent something, you build it, you ship it, and you ship it out to the market, but again, it's shipped as a connected device, which is able to give you constant information back as a manufacturer, permissions allowed, and all the various controls that you might have to put in there to not cause your customers any trauma. But the important part is that you have live instrumentation about what's being done with this, is it even being used, which features are more important, what's the stress it's putting on the mechanics of something, and you're able to feed that back in to your upgrade process. And your upgrade says, do we build a complete new product or do we ship a patch? And so now it's saying, well, that car, we can make those brakes a little bit better by tweaking this bit of software and sending it up out over the air. It is now a service loop that you're able to deliver to your customer. And likewise with even the things that are making the things, the people that make the machines that run the production lines are able to tell what's going on that production line and send maybe updates to improve the life of that machine. But many organizations aren't set up to be those service industries because they've been set up to be a packaged good or a thing that they ship, forget about until they do the next one. So there's interesting challenges for organizations to switch to that way of working. There's also, the kind of possible misnomer that people are being factored out in all this, because a lot of this is about industrial automation, and we certainly see people being taken out of dangerous jobs. But in all the conversations I have with OT companies, people always come up as an incredibly important part of the entire business, because these machines still need fixing, things still need doing in ways that aren't necessarily going to be automated for a very long while. But at the same time, if you're working in the IoT industry, when we look at and ask companies, have you got the right people? Can you get hold of them? We see things like data analytics and security on the left there are incredibly difficult to get the right people for. These are not things that have had years and years of training and degree level things for people to study to get to, because we've been in a different kind of software industry. But now the things that you need to do with security and things you need to do with data analytics are suddenly in demand because there's all this data being generated on that big pipe I showed you before coming back from the machines. And that's just in manufacturing, not necessarily in the rest of the industry. But then there's this other kind of twist to this. And the fact is that in all the things that we talk about and all the IoT platform stuff, it's all about big companies that have got IT departments to actually enable this stuff. And when we look at kind of US demographics here, which will correlate pretty much with lots of other places. In fact, there's there's fewer large companies that are able to absorb this kind of, here's our IoT platform, here's all the fancy stuff, integrate it, get on and do it. And most of the companies are small companies. They are people and contractors and individuals that are kind of gathering together that may be brought together into a large project and be bringing their own tools and their own tool sets with them. And the problem is going to be, how do you integrate that, bring your own IoT into like a big construction firm, or as they're building a building? How do you pull those things in? And we're missing that mesh of network in what's happening with that. But there's lots going on in the tooling that will help those smaller companies and that long tail of people. And that's where, luckily, Emily's on the line and is now going to talk and try and help understand about Cobots. So Emily, can you tell everyone what a Cobot is?
Sure, Ian, and thanks for handing it off. So a Cobot is short for a collaborative robot that can work alongside humans on a factory floor. We see it as an emerging technology that can address what you just mentioned, the fact that small industrial companies lack the skills, resources, and adaptability for variations in production. So it's an area that 451 has recently been looking into, and we'll be publishing a report that will give a broad overview of the market very soon. So the concept of cobots has actually been around for quite some time. For example, there were 2 engineering professors at Northwestern University who began research funded by GM in 1995 on the topic. And then there was the EU's 2005 initiative for SMEs and manufacturing, which also involved the idea of a cobot. However, buzz has really heightened over the past few years, especially. So when we think about industrial robots, historically they've been quite bulky and jerky, posing safety risks to human workers and therefore needed to be confined to cages. But these cobots are now designed to be safe enough to operate in a workspace shared with people, and this is due to improvements in computing power, artificial intelligence and machine learning, sensor and vision technology that can detect surroundings to avoid collisions. And cobots are all about augmenting and enhancing the capabilities and productiveness of humans. They're meant to act as tools that can assist workers rather than fully displacing workers. And they'll, for example, assume repetitive or menial or physically demanding tasks for humans like machine tending or packaging. And this ideally yields for a business higher productivity, quality, and consistency, as well as the creation of new roles related to the maintenance and operation of the robots or strategy and innovation. So other important features are that they're agile, transportable, and easy to deploy. They have simpler programming than regular robots and components that can be swapped in and out, so more of like a plug-and-play capability. And then in terms of vendors in the space, many people know of Universal Robots and Rethink Robotics, but there are a variety of other vendors that are showing interest in a cobot investment. Suppliers range from more established makers of industrial robotics like Bosch and Fanuc, and startups like Casso Robots. And they might either focus on providing a comprehensive offering that includes both the hardware and the software, like the applications providing an interface to monitor the robots, or they might focus on solely end-of-arm tooling, which are parts needed for specific applications. And then just to give an idea of these machines in action, I want to highlight a couple of use cases too. The first is a large multinational automaker that robots at their plant in Munich are helping humans to load in reinforcements for side members of vehicles. So in this process, the cobots and humans take turns with certain assembly tasks. And then the second is a smaller company that implemented Cobots, it's a manufacturing company based in Michigan, and they're using cobots to load parts into a honing machine and then transfer those parts to a wash station and then a drying station and then package it off for shipment.
Excellent. Thank you very much. So it's interesting to hear the trend, as we've kind of spotted here, for cobots, because it is very much, as Emily said, about augmenting what humans can do, not replacing them. We still have those giant industrial robots, but that augmentation kind of fits into some of the other stuff that I look at as well. So I cover VR and AR, so virtual reality and augmented reality, particularly as it fits into industrial IoT. And for those who haven't come across it, I mean, you've probably seen VR and see that maybe as a gaming headset that you just stick on your head and disappear into a world. But though the VR pieces are great for immersing people in data and immersing people in training applications and seeing what they wouldn't normally be able to see, like how do you get to the fire escape on an oil rig. That's a really important part of engaging with people. But the augmenting of people and augmenting the workforce with augmented reality potentially has a greater impact within industrial use, particularly because if you are a lesser skilled worker who hasn't maybe seen the machine that you're going to go and try and fix, to be able to be presented with some information in potentially a heads-up display, to let you know what is wrong with that machine, what's actually happening with it at that point in time, or to be remotely guided by the actual expert who's back at base. You've got your hands free, you can see what's going on, it's locked into the physical view of the world that you have. It's a much better way to engage with somebody than just saying, well, here's the manual, go off and see how you can fix it. And one of the interesting things with these kind of approaches, when you've got heads-up displays and you've got information, it is the user interface for IoT, because all the instrumentation on the machines and all the piece of information that you're engaged with are location-based as well. They are around you. And you then become an IoT sensor nest yourself, because you are where you are, what you're looking at and what you're doing and what you're impacting. You're becoming part of the system. So it's not just an AR thing about just give me a small piece of information. It's actually being totally integrated and more efficient and more safe within those environments. There's whole presentations we can do on AR and VR, but and if any of you know me, that's what I've been doing for many, many years. So I'm happy to talk about that offline. I said we can't do an IoT presentation without talking about security and trust, because this is the number one issue in this whole thing that I've been talking about. So we're talking about what's missing. When I showed that loop, the virtuous loop of you being able to instantly do an over-the-air patch and fix everything, and everything's running as a service, that's re-represented here, and that's at the top. And that's saying, right, this is you, this is your product, this is your boundary, this is what you're interested in, this is your security camera, this is your car that you make, this is your weaving loom, the same thing. The problem is that not only in this loop are you increasing your attack vector, that there are ways to possibly hack that loop and make bad things happen to all the machines. You also have the potential to impact everybody else on the planet and everybody else's machine and device. So anyone, any person or any organization creating something that sits as a connected device that has access to the internet resource in that way has to just dive in and sort security out straight away from the very start, because the impact across from the leverage that you get from having one tiny hole in a device now impacts everyone. I mean, we've seen it with PCs before. We've understood what happens when you don't patch your PC and viruses get in. It destroys things. The level that we're dealing with here is very much increased. And so this isn't just about fixing the manufacturing process. This is about the things that come out of the manufacturing process as well. We all have to be involved with that. And we know from the surveys that people, when we ask them, they're concerned about security. So it's the authentication of these IoT endpoints. How do you know that thing that's talking to you is supposed to talk to you? But it's also, they're physically unsecure now, because these things that maybe are manufactured, or these things on maybe in the shop floor. People have got access to them now in all sorts of other ways they maybe didn't have before. And when we look at it again, in looking at the whole picture of the concerns, there's the concerns about security in the top right there, but there's the whole thing about everybody's concerned about IoT security. That is has to be their focus, and that should carry on being their focus because of the impact that they can potentially have across a much wider area. And it's not to be misunderstood how important that is. But, as we said before, the skills to be able to deal with that security in these sorts of environments are in very short supply. So, ideally, universities and governments and companies have to start training people up to understand these kind of environments, not just the traditional IT security environments, because it's got a slightly different twist to it with what you can hack and what can go wrong. But not trying to panic everyone, but I would worry. So anyway, so the future, because that's more bright when we consider the future. If we think about and look at what companies are doing and where all this stuff is heading. This year at Hanover Mess, the giant industrial show, it was very clear that the big guns of OT, the big machine makers, were very much saying, look, we've been telling you about all this IoT stuff for the past 3 years. Everything's been through enough of a cycle that now's the time to get on with it. And that kind of focus to say, yes, we're there. We know what we want to wire up. That gets us to the point of saying we're actually connecting machinery now. And that's what we see in our survey data that we've got now and in 2 years' time represented here. We've got people saying they are at the top there. Their focus at the moment is production, manufacturing, monitoring, and inventory monitoring. The kind of the basics of connectivity. But in 2 years' time, they see that less of a focus, and they see that dropping down. So the dark blue bar is bigger at the moment because it's a big focus, but it will drop to the lower blue bar over 2 years. So that makes sense. The connectivity gets kind of dealt with. So then we move down to the compute section, the bit where you're actually doing something with all this data, because there's no point collecting it and not doing anything with it. And so then we see in the survey data that the focus at the moment the focus is going to increase over the next 2 years, and people I know that they need to do more with their analytics, and they need to do more with machine learning, and they need to do more with the computing of what you're taking this data to do. But the other thing under that then is about people. I said people are very important in manufacturing, in the manufacturing world. It's not about getting rid of them, it's about giving them the right task to do. And connected worker, which is AR and VR and all the other various instrumentation that we can put on humans, again, is a thing that's going to increase over the next 2 years. So these companies are saying, yes, we now know we need to focus on that. But interestingly as well, under there, it's not labelled as people, but it could be labelled as people, is smart robotics. So just saying, well, we've got a very clever welding arm is one thing, but smart robotics, things that are looking at the world, things that are processing what's going on, things that are working with other people, like the Cobots that Emily described, they are being recognised as something that's on the increase as well. So we can see from that kind of future, it maps out again to the increase in getting the basics done right, will then lead to the fact that you can find these new services and things on top to be able to do something interesting with them. We've got fleet tracking on there as well, but that stays pretty static because people understand moving stuff around. But the important thing is to look where you are, or where the companies that you work with are on that journey. Are they connected yet? Because not everyone has got this sorted. I'm not suggesting that everyone's there yet, because they're clearly not, but they might be further on that line than they even know. And so the big push for applying machine learning and applying AI and applying analytics is sitting there happening now. We're on that journey. But coming along with that, don't forget the people and don't forget the Cobots. And with that, I will open it up to any questions. Thank you very much, and thank you, Emily.
Thank you, Ian. Thank you, Emily. Don't forget, please submit your questions in the questions from the audience section of your Bright Talk platform. In the meantime, we do have some questions. In your opinion, what are the most important IIoT M&A transactions in the past few years?
Excellent, that's a good one. There was certainly a very important one when ABB bought B&R. It was quite a very significant kind of adding to their portfolio to further into industrial automation. And also recently, Rockwell's investment of, I think it was $1 billion in PTC. So Rockwell taking their kind of rather than just building up their business or adding to it, they've kind of invested in somebody that's in the design and AR and VR end of things, in understanding what's going on with some of the data in IoT and how to engage with people with it, and that kind of showed a seriousness of action there, obviously, because that's quite a significant investment as well. There's been a few, they're not necessarily M&A, but the emboldening of things like Siemens MindSphere. So the newer version, version 3 that they're on, brought in some newer technology that gives it a lot more scope to connect to a lot more devices and pieces kind of out of the box. And that's interesting given where Siemens are on their journey from a traditional kind of OT place. Obviously, they're very influential in the whole Industry 4.0 movement, but now they're kind of like 40% software company, so they've changed themselves, which isn't quite the same as M&A, but that's an evolving piece. So now they're sitting there working on things like OPC UA and working alongside Microsoft, who are also working on OPC UA, which is a protocol that helps shuffle data around in a kind of competitive, cooperative battle. Instead of hand over mess, ours is showing that they could both do this particular way to get connections going with PubSub, and that was growing that side of the business.
How common is looking at old IoT data to improve operations with analytics? Is IoT mostly for real-time operations?
No, that's a good question, because that's both is the answer. The real-time operations, dealing with streaming analytics from something is obviously incredibly important, but you need context in the first place, and historical data that maybe has been collected and put in historians and things, sometimes it needs sanitizing, and it needs the skills of data analytics to kind of people to get into it. But looking at what's been happening is the thing that informs all the analytics things in the first place. It's very difficult just to throw an analytics thing onto something and it fix itself. So that data is incredibly valuable.
Great. The last question I have, unless we get some more, so if you have a question, please make sure you submit it to the questions from the audience. This question, though, is who are the big players in edge analytics? But I think is that still an evolving space, Ian?
It is an evolving space. There are kind of lots of companies, startup companies like, well, they've been around a little while now, but startup companies like Foghorn are totally focused on edge analytics and machine learning, and are therefore partnering with all the companies, both the OT companies and the IT companies, and the giant cloud providers of this world and things, to bring their technology in. They're not the only one doing that, but they're getting a lot of attention, a lot of traction, but it's you see the large companies, the Amazon or the AWSs of this world, and Azure, and IBM with Watson, trying to say, well, we've got our big machine learning and big AI things on the cloud, but can we let's engineer it and break chunks off so that you can take that model down and drop it close to the edge. So the whole move towards edge computing is one that that has to happen. If the assumption that everything was going to be done in the cloud is kind of has been put to bed, I think, because it's obvious you need to do things at the edge, and manufacturing shows you need to do things at the edge because the machines are working so quickly and doing so much. But the edge analytics is one portion of that, obviously. But also then we've got which I've certainly talked about before, we'll eventually get to a continuum of compute from device to cloud, which includes edge. An edge just keeps moving, so edge is wherever it needs to be. So that if you're trying to do something really, really locally, you use as much compute power as you've got close by. But if you then got something more complicated to do, you kind of go to the next layer of the onion skin. It's not necessarily a kind of just three or even two platform architecture. I think we're going to end up with much more smoothing of where the compute happens. And there's lots of people working in fog computing areas like that, which is an emerging area, but it's kind of edge analytics is the thing that's going to push people to say, right, well, I need to do this edge analytics, but I haven't quite got enough power, or I need some more data from somewhere else.
Interesting. Let me just see here. Two more questions did come in. The first is, there are multiple industrial vendors and cloud players offering IIoT platforms. Why do you think industrial vendors are offering IIoT platforms to drive HW sales, or to drive SW sales, or even drive service sales? What's your view on cloud players' strategy on the manufacturing vertical?
Okay, I'll try and unpack that one. That's a good one. I think the industrial players have to start, or are kind of forced into the IoT platform space because the IoT platform space is where all the data is gathered and how you wrangle things from one machine to another. So it becomes a kind of plumbing element that's required to get the connectivity to happen. So if you have a platform and they all end up having to support all the other protocols and all the things that are coming in now, but you've at least got some sort of centralized handle on what's going on in the environment. And say a lot of them end up being the same. It'd be very difficult to divide some of them up. And some of them are white labeled, similar ones anyway, under the covers. But to say I can give you this complete service if you want it is completely different from I'm going to have a different IoT platform and I'm going to lock you into it. So whereas previously manufacturing and OT companies may have been lock-in, just as cloud providers may have been lock-in, the kind of sensibilities of enterprises now, they don't want that kind of lock-in. They certainly don't appreciate it. So everything has to work on everything. So you therefore need an IoT platform to match the other person's IoT platform in case somebody wants to use yours or theirs. So it kind of comes with the package. And so they're not necessarily doing it to drive software sales particularly, but they're doing it to say, possibly, as you would see with the cloud providers, if you use my way in of this common approach to something, you'll then get access to my extra special services that I might be able to provide for you. So with cloud providers, it's, all this cloud stuff's normal, but you can use my interesting text parser or my particular AI platform, and it's easier to use it because if you come in through me. And so the same thing happens in the industrial thing, saying, well, then you can maybe use our predictive analytics model on your machinery because it's easier if it comes through our platform. So I think it's kind of a big melting pot of saying, well, we're an industrial IoT operating system. Here's a few applications to kind of sit on it, but each of the companies has to provide their lump of that operating system. Otherwise, things don't gel, and it seems to be kind of walled gardens approaches. And cloud players, I'm not sure that they. Have I lost you? Anyway, I'm not sure that cloud players have a particular point in that.
Ian, I think
sorry.
are
we still on?
I believe so.
Okay. If you can hear me, that's good. I don't know if anyone else can still hear me, but you can.
I mean, we can ask the last question, and if
please.
people can still hear us, they'll get the question. If not, we'll connect with this one questioner offline. Where do we go for the best practice architectures for IoT analytics?
Well, that's the problem. I think there isn't necessarily a best place to go for any of these things. The best practice. There are things coalescing to try and say, like the Industrial Internet Consortium, things that people are coming together in test beds to say, here's a way to deal with this. Here's a way to kind of get the companies together to sort some stuff out. But the kind of architectural patterns and the best practice patterns are not embedded in yet, because we're still at that connectivity phase. So there's not kind of a big central resource that you can just say that's the way this works, because each one is about those algorithms trying to be trained in a particular way. I think that's yes.
Well, excellent. In the meantime, if you guys didn't see it on the last screen, you can send any additional questions to Ian directly via email, but he's also very active on Twitter, and you can follow him at ePredator on Twitter and send him some DMs of questions you have on IIoT. And Emily, you're also on Twitter, right? Do you want me to share around your Twitter handle?
I actually don't know if I can remember my Twitter handle off the top of my head, because I'm not as active as Ian is, but I'm working on it.
If you have questions for Emily, then please ping them to me and I'll hook you up.
Yes, absolutely.
But thank you again for joining us. If you did experience any technical difficulties at the end, we apologize, and hopefully we'll see you again next time. Don't forget to leave us some feedback in the feedback from the audience section, and we'll see you next time. Thank you again.